Imagine a treasure trove so vast that it dwarfs any gold reserve ever discovered on land. Picture a hidden world beneath the waves, where untold riches lie in wait, just beyond our reach. Now imagine this treasure hidden in plain sight, dissolved within the very waters that cover most of our planet. The oceans, which make up over 70% of the Earth's surface, hold secrets that have fascinated humanity for centuries. This, my friends, is not a scene from a pirate adventure, but the intriguing reality of our oceans. The idea of vast underwater wealth has inspired countless expeditions and scientific inquiries. Scientists estimate that there are approximately 20 million tons of gold dispersed throughout the Earth's oceans. This gold is not in the form of nuggets or bars, but rather dissolved in the water itself, making it a unique and challenging target for extraction. This staggering amount, if gathered, could theoretically provide every person on Earth with several kilograms of the precious metal. Imagine the impact such a discovery could have on the global economy and individual wealth. But before we set sail with dreams of becoming oceanic gold miners, we must understand why this underwater gold rush remains a distant prospect. The challenges are immense, and the technology required is still in its infancy. The truth is, this gold is not easily accessible. It is not simply lying on the ocean floor waiting to be scooped up. Instead, it is dispersed in minuscule amounts throughout the vast expanse of seawater. It exists in extremely dilute concentrations, measured in parts per trillion. This means that for every trillion parts of seawater, there is only one part of gold. The sheer scale of this dilution makes extraction a formidable challenge. To put this into perspective, extracting a single gram of gold would require processing hundreds of thousands of gallons of seawater. The energy and resources needed for such an endeavour are currently beyond our reach. Despite these challenges, the allure of ocean gold has captivated dreamers and scientists for centuries. From ancient mariners to modern researchers, the quest for underwater riches has been a driving force in the exploration of our seas. Join me as we delve into the science, history and future of this underwater treasure hunt. We will explore the technological advancements that may one day make oceanic gold mining a reality and the environmental considerations that must be addressed. The journey to unlock the secrets of the ocean's gold is just beginning, and it promises to be an adventure like no other. Gold's journey to the ocean floor is a tale spanning millions of years, shaped by geological upheavals and the relentless forces of erosion. Deep within the Earth's crust, molten rock or magma carries dissolved gold towards the surface. As this magma cools and solidifies, it forms gold-bearing veins within rocks. Over eons, rainwater combined with the erosive power of wind and ice gradually wears down these rocks, releasing tiny particles of gold. These particles, carried by rivers and streams, eventually find their way to the ocean. But the journey doesn't end there. Once in the ocean, gold undergoes further transformations, influenced by the complex chemistry of seawater. Seawater is a complex chemical soup containing dissolved salts, minerals, and even trace amounts of precious metals like gold. This vast, seemingly endless body of water holds secrets that scientists are only beginning to uncover. The gold within the ocean is not in the form of nuggets or flakes, but rather it exists in a dissolved state intermingled with countless other elements. While gold is generally unreactive, the unique conditions of the ocean environment allow it to dissolve and disperse throughout the water column. The ocean's chemistry is a delicate balance, influenced by a myriad of factors that create the perfect conditions for this dissolution. The interaction between gold and seawater is a fascinating dance of chemistry and physics. This dissolution process is influenced by factors such as salinity, temperature, and the presence of other dissolved substances. Salinity levels can vary greatly in different parts of the ocean, affecting how gold and other minerals behave. Temperature changes can also play a significant role, as warmer waters can hold more dissolved substances. The presence of other chemicals and minerals can either facilitate or hinder the dissolution of gold. As rivers deliver gold particles into the ocean, they react with the seawater, forming various chemical complexes. These rivers act as natural conveyors, carrying gold from the land into the sea. Once in the ocean, the gold particles undergo a transformation, reacting with the salts and minerals present in seawater. This process creates new compounds that are more stable in the marine environment. These dissolved gold complexes are then transported by ocean currents, spreading the precious metal far and wide. Ocean currents are powerful forces, capable of moving vast amounts of water and the substances dissolved within it. These currents can carry gold particles across great distances, distributing them throughout the world's oceans. The movement of these currents is influenced by factors such as wind, the Earth's rotation, and differences in water density. Understanding the distribution of gold within the ocean's depths requires a closer look at the forces that govern its movement. Scientists use advanced technology to study these currents and the way they transport dissolved substances. By mapping the flow of ocean currents and analyzing the chemical composition of seawater, researchers can gain insights into the complex processes that distribute gold and other minerals throughout the ocean. This knowledge not only enhances our understanding of marine chemistry, but also opens up new possibilities for the exploration and potential extraction of these precious resources. Section 4. Foolish dreams or near reality. The quest to mine the ocean. The dream of extracting gold from the ocean is not a new one. This idea has fascinated humanity for centuries, capturing the imaginations of explorers, scientists, and adventurers alike. The vast, uncharted waters of our planet have always held a certain mystique, promising untold riches and secrets waiting to be discovered. For centuries, alchemists and entrepreneurs have sought the key to unlocking this underwater treasure chest. They believed that the ocean, with its boundless depths, held the potential to change the fortunes of nations and individuals. The allure of underwater riches has driven many to embark on perilous journeys and invest in groundbreaking technologies. One notable attempt was made in the early 20th century by German chemist Fritz Haber. Haber, a Nobel laureate, was renowned for his contributions to chemistry, particularly in the development of the Haber-Bosch process for synthesizing ammonia. However, his ambitions extended beyond the laboratory. Haber, driven by the ambition to help Germany pay off its war debts, believed that seawater held enough gold to make a difference. He theorized that if he could extract gold from seawater, it would provide a solution to the economic challenges facing his country in the aftermath of World War I. He dedicated years of research to developing a process for extracting gold from seawater, even embarking on an expedition across the Atlantic Ocean to collect samples. Haber's determination was unwavering, and he assembled a team of scientists to assist him in this ambitious endeavor. Despite his best efforts, Haber's project ultimately failed. The challenges he faced were immense, from the technical difficulties of extracting gold to the sheer scale of the ocean itself. His experiments, though meticulously conducted, did not yield the results he had hoped for. His research revealed that the concentration of gold in seawater was far lower than initially estimated, making extraction economically unviable. The dream of turning the ocean into a gold mine remained just that, a dream. Haber's work, however, was not in vain, as it contributed to our understanding of the ocean's composition and the limits of scientific endeavor. However, Haber's story serves as a reminder of both the allure and the challenges of ocean mining. Today, the quest to mine the ocean continues, driven by advances in technology and a growing demand for resources. Modern scientists and engineers are exploring new methods and materials, hoping to succeed where their predecessors did not. The ocean remains a frontier of human curiosity and ambition, a testament to our enduring desire to uncover its secrets and harness its potential. Section 5. The Golden Challenge. Why extraction is so difficult. While the ocean may hold vast quantities of gold, accessing this underwater treasure trove presents formidable technological and economic hurdles. The primary challenge lies in the extremely low concentration of gold in seawater. Extracting a single gram of gold would require processing massive volumes of water, demanding energy-intensive and costly methods. Current technologies such as adsorption onto specialized resins or electrochemical techniques remain inefficient and economically unfeasible for large-scale gold extraction. Furthermore, the environmental impacts of large-scale ocean mining remain a major concern. Extracting gold from seawater could disturb marine ecosystems, potentially harming marine life and altering ocean chemistry.